Okay, good. So to start us off, I just want to, rehash some very simple stuff that you might be familiar with. All right, let's start with the real numbers, right? Because all of the mathematics that you will be dealing with will deal with real numbers, right? You're not going to go out of the real numbers, right? And as a little review, we're going to just go through quickly back the different sets of numbers, right? And you probably heard of what we call natural numbers. You heard of this before? Natural numbers, right? And I think there's a symbol like this, a little n. Some textbook would have like a shadow like on the end here, natural numbers, and that's equal to numbers from 1, 2, 3, going on to infinity, right? Those are the natural numbers. The name kind of fit in that the natural numbers is how you normally count, right? How you naturally count. How do you count? You don't start from zero, right? You usually count 1, 2, 3, naturally, that's how we count, right? I think when zero comes in is when we refer to what we call whole numbers, whole numbers, right? And that's a W. And those start from zero, and there's where zero comes in, right? And it goes on to infinity, right? So that's a little addition to the mathematics, this zero here, right? Natural numbers start from zero. Then there's what we call integers. Integers. And the symbol is not I, as we would think, that N comes, okay, N is from here, W is from here. And you might want to say, oh, the symbol is I, but no. The end is, the symbol is Z, right? Z. And they include, and of course, a little bit of research, you'll see that this Z comes from the name Zahlen, Z-A-L-E-N. I think it's German. It's a German term for integers, right? You can research it, right? So the integers are okay. It involves the negative numbers. So let's go with or from we taking from -3, -2, -1, 0, 1, 2, 3. We're not gonna go beyond here. Yeah. So all the negative numbers that are of whole number magnitude, right? -4, -10, -100, they're all integers. But they must be of whole number magnitude. What I mean by that, if you were to find the size of the number, right? It's a whole number, right? Like the size of -3 is 3. When we talk about the size of a number, maybe I can put it on a number line. When you speak of the size of a number, okay. All right, let's go here, -1. Good. When you speak of the size of a number, you're really talking about how far, or what's the length of this line segment, right? What if you're talking about the magnitude of 1, what's the length of this line segment? It's 1 unit, right? Similarly, -1, the magnitude of -1 is also 1, right? So same goes for, let's say, 2. 2, the magnitude of 2 is 2. The magnitude of -2 is also 2, right? So the magnitude, let's say, of 1 and -1 is the same. The magnitude of -2 and 2 is the same, right? What makes them different is their position on the number line. -2 is less than 2, right? As a matter of fact, negative 2 is even less than 0. Negative 2 is less than minus 1. So based on where you are in the number line, right? So going this way, you get less, right? The numbers get less. And going this way, the number gets greater, right? But their magnitude, like the magnitude of 3 is 3. The magnitude of negative 3 is also 3. The magnitude basically is the length of that line segment from 0 to the number, right? So when I say the integers, right, include both negative and positive numbers that are of whole number magnitude, right? So like 1.5 wouldn't work. That's not, if the magnitude of 1.5 is 1/2, right? That's not a whole number. It doesn't have a whole number magnitude, right? So it's not an integer. We'll come to what it is just now, right? You think you get that? The value of a number is determined by where it is on the number line, right? Like negative 3 is far less than 0, right? 0 is less than 3. So as you go to the left, you get less. As you go to the right, you get greater, right? Keep that in mind. So let's talk about numbers like 1.5 and all the fractions we have, right? Let's talk about that. So we're going up a little, and then you have what we call rational numbers, right? And the symbol they use is a Q. So I should write that. Let me write out the word. Okay. Rational numbers, right? Rational numbers, as I said, is a symbol Q, right? And it comes from, from division, you call something quotient, right? It's a result of division, right? So that's where they got a Q from. And I want to write, maybe I'll put a few numbers in, numbers like, there are an infinite number of rational numbers, but let me, instead of trying to put them in a set, I'll give you some examples, right? They're numbers, okay? They're numbers that could, I should say real numbers, right? Real numbers that could be written as a fraction, right? As a fraction. And some textbooks would add in the word exact fraction, right? So that would mean all the natural numbers are rational numbers, right? Because like 1 could be written as a fraction, 1/1, right? 0 over 5, still 0, right? But it's a fraction, right? Negative 3 over 2. So, oh, sorry. What am I doing? Negative 3 over 1. That's negative 3, right? So the number can be written as a fraction, right? It can be written as a fraction. So you just don't look at a number and say, man, 2 is not a rational number. It's not a fraction. But could it be written as a fraction? That's the thing. So 2/1 is a fraction. It's equal to 2. So 2 can be written as a fraction. So it's rational, right? And then finally, we'll talk about what we call irrational numbers. Irrational numbers, right? And we usually use the symbol a Q with a complement sign out here. And I'll show you why just now. And this one doesn't mean well, some students are really disgusting. Yeah. Whole day they're calling me, including nighttime. Yeah. Where were we? Yes. So what irrational numbers are shouldn't be hard, because if rational numbers are numbers that could be written as a fraction, then irrational numbers, I can change this word for the sake of this definition. Numbers that can, right? Let me use the word can be written. So irrational numbers are real numbers that cannot, right? That cannot be written as an, oh my, as an exact fraction, right? And let me give you a few. You all know of pi, right? Pi. Pi can be written as an exact fraction. Nobody knows the value of pi, right? So that thing, 22 over 7, no, this is just an approximation. That's not pi. 3.14, right? Um, so let's take another number that is an irrational number. Root 2. Root 2. Can't write that as an exact fraction, right? Root 3. Let me see if I can move up this whole thing. Yeah. Root 3, root 5, There's a famous number in mathematics called E, right? Oh, by the way, I hope you have a notebook and you're not just slavishly, you sit down and you're just watching me. And as somebody says, they have a video, so I'll watch it back. Good to have a notebook, right? And jot down things. Sometimes you might not need them to watch back the video, right? And with notebooks, you could always, like when I say, man, research, what's E? What's the number E? Right? What's the number E? Right? So you can write that down in the Neperian number, right? E. Google it and see what it says, right? So there are lots of numbers that can't be written as an exact fraction, right? And therefore, those fall into the category of irrational numbers, right? If we were to throw all this information on what you call a Venn diagram, you've probably heard about that before, right? So the universal set will be real numbers, right? And then, okay, we started off with natural numbers. Then all the natural numbers fit into whole numbers, right? Plus there's zero out here somewhere, right? Remember? And then you go here now, and you got the integers, right? And then all these numbers are rational numbers, and outside here are what we call irrational numbers, right? So if you're not rational, you are irrational, right? And that's the extent to which you will go when it comes to dealing with numbers. You're not going to deal with any other kind of numbers, right? All the numbers you will deal with will be real numbers. Of course, there are other number sets within the real numbers, right? Like you hear of even numbers, odd numbers, prime numbers, you hear of composite numbers. So they have others, what they have? They have square numbers, right? I'll give all of you an opportunity to do some research, or I have to tell you everything. You have Google nowadays, can tell you anything, right? You could Google what these are, right? And their relationship and all of that, right? Good. So let's move away from this, and I want to talk a little about something else in your course outline, right? And that has to do with well, they refer to it as mathematical operations, right? Now, what we're talking about is order, the order of mathematical operations, right? I know my writing isn't of the best, right? And that got to do with, well, you have a set of operations to perform and some real numbers. Let's just throw one up, Maybe you have 5 minus 2 bracket 3 plus 1 um, square divided by, let's say, 2, You have a complex thing like this, and you're told to evaluate something like this. Evaluate that. There's an order in which we do things, right? One might be tempted to look at this and say, let's start from here. 5 minus 2 is 3. Okay, all right. Now we put this in here. What do we do next? Right? Maybe we multiply the 3 into that, no? And get 9 plus 3 squared divided by 2. Is that what we do? Right? No. All of this is garbage. No. There are rules as to which operation you do and the order in which they're done, right? And that's what we're referring to here. The order of arithmetic operations, right? So I'm going to go with that just to give you an overview, and then we'll look at some examples. And there's a nice, a little memory aid, right? That you can use to remember how it's done. Right? I don't know if you remember this from high school. Anybody know what the B means?
Bracket.
Bracket.
Okay, you work out what's in the bracket first, right?
Yes, sir.
Yes, sir.
Work out operations in the bracket first, right? Okay. What is O means now?
Of.
What is this of now? What's that? Huh? Anybody can elaborate a little more? Of?
Multiply.
But I think this M is multiplying. Of the O can be multiplied and the M will be multiplied. Can't get it two ways, right? I think the O refers to powers of, right? So work out powers of numbers, right? So after you have done brackets, you can now work out powers of numbers, right? Then division, then multiplication, right? I'll tell you a little about these two, right? They can be done in the order they appear, right? There's an E here, they appear. So even though they say you have to do division before multiplication, you can very well do multiplication before division if that's the order they appear. I'll illustrate just now with examples, right? And I'll tell you a funny story. What does this A mean? Anybody knows?
Pardon me, sir?
What does
Addition, sir.
Oh, the A is addition.
Okay, I think you need to qualify that better. Add positive numbers, right? Add positive numbers, not just add. I'll show you again why I'm saying this. And lastly, subtract, right? However, these two operations, like division and multiplication, can be done in the order in which they appear, right? So they can be done in the order they appear, right? Good. So we'll deal with some examples with brackets and powers of and so just now. I want to deal with this division and multiplication thing, right? And why I'm saying that even though division, say, this thing is saying do division for us, you can do them in the order in which they appear. And I'll tell you a story quickly. When I was a young teacher, and I'm talking about nearly 30 years ago, so, you're young, you're full of energy, you think you know it all, because that's how young people operate, you think you know it all, and nobody can tell you not you know it. You've been to university and blah, 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 Good. So I remember I went to a seminar, a famous seminar, and we talked about BODMAS, and we had this division, then the multiplication, right? And I was telling them, you have to do division first. You have to. And then you do multiplication. So there's a famous man. He's very popular in Guyana. Those of you, if you're living in environs of Georgetown, you'll hear of Mohandat Gulsaran. Anybody know that name? Mohandat Gulsaran?
No, sir.
Okay, you don't know that name. All right, good. So I remember he said, okay, all right, if you're fighting over, you must do division for us, right? So he put his problem up on the board. 10 multiplied by 2 divided by 5. So I went out and I say, man, and mind you, this was a seminar of all the math teachers in Region 6, right? And I was teaching at multilateral school at the time. And I remember, but people think that, well, the best guy will be at multilateral, and multi sent their best to this seminar. So I went out and I'm arguing that you have to do 2 divided by 5 first, because that's what the rule says, right? So I did it, and 10 multiplied by 2 over 5, right? I wrote it like that, and 5 multiplied by 1 and by 2, you get the answer 4, right? So I did that, and the guy said, all right, okay, all right, good. So the man says, do it in the order in which it appears. So if you do it in the order in which it appears, you get 10 multiplied by 2, you get 20 divided by 5 equal to 4. You see what happened there? And guess what? When I did that, the entire audience, which is about nearly, about 50 people, they start to cheer because I think I learned my lesson. I never forgot, right? I was thoroughly embarrassed. I wish that the floor had a hole and I could have fallen through. But those lessons I'll never forget, right? I like to tell the story, even though it embarrasses me, but I learned my lesson. So yeah, look at this. Insisting on doing division force makes you, you produce a fraction that is horrible and, that sort of thing. But you could have very well do the thing in the order in which it appears. Look here. Very, very simple. Right? Good. Let me go to our next one. I don't have a story to go with that one. So look at this one. And I'll tell you, even at the university level, a lot of my students would have this wrong. So I'll do this, okay? 10 minus 2 plus 3. Right? And all we said just now, you have to do addition first and then subtraction, right? That's the order. So if you were to do that, what will you do? What will you add and so forth?
So I will minus the 10 from the 2. Then I would add 8 plus 3.
You minus the 10 from the 2? How you do it? The 10 in front here, You mean the
Sir,
minus the 2 from the
first,
10?
Yes, sir.
No, let's go with this rule. The rule says you have to add first. What will you add first? That's what the rule says,
So,
right?
so could you add the negative 2 plus?
Or you're adding negative 2 and the 3. Okay. But this is a subtraction sign. This is not a negative sign. What will you add first?
Sir, first, I think I would have bracketed off first to make it easier for me.
Bracket what
So
off?
I would have put 2 and 3 in a bracket. And I
So
would
you,
have add 2 and 3 first and then minus it by the 10.
oh, all right, good. So we are seeing something here now, right? Remember I said this A doesn't mean adding force. It means adding the positive numbers force, right? And when you look here, somebody did say it, right? But I'm deliberately wanting to mislead the class, right? Because you know when you know that you have adhered to the rules, you got to hold your ground, right? So when I doubted that, everybody caved and gone all other directions. So somebody said, okay, you could add the negative 2 and the 3. But the rule says add positive numbers first. So the two positive numbers are the 10 and the 3, right? 10 and the 3. So the 10 and 3 will give you 13, and then you subtract the 2 and you get 11, right? So if you add positive numbers first, the 10 and the 3 gives you the 13, and then you subtract the 2, right? Alternatively, as I said, you can do it in the order in which it appears. So you just go 10 minus 2 is 9. 9 plus 3, 11. You see? So if you're adding, you have to add the positive numbers first. And then you subtract. Or you do it in the order in which it appears. Right? However, somebody did say something that makes sense. And I want to... what's going on here? My whiteboard is moving. What's going on? What is doing that? Every time I do that, what's happening there? I might have to refresh this whiteboard because it's behaving crazy. All right, let me go back to it. Let me do another whiteboard. Can you see a new whiteboard now?
Yes, sir.
Good. So somebody said this, 10 minus 2 plus 3, right? And they said to add negative 2 and 3, which is not a bad idea if you really know what you're doing, right? So if you do that, negative 2, you could actually treat the subtraction sign like it's negative, right? So you're actually saying, okay, this is like 10 plus negative 2 plus 3. So you can do this piece, right? And you get what? You will get no, you won't get the right answer there. No, you see that? Look at that. If you do that, you will get what? 10, what's this? Plus 1. Oh, you get the right answer. Yeah, you'll get the right answer, right? So yes, you can do that, right? You can treat this as a plus sign, right? And put in this subtraction sign as a negative, right? So these two, when you add them now, you get the 1, and you add it to the 10, you get 11. So that's an alternative, but you really have to know your negative and positives, which we'll touch on a little later, right? So that person wasn't wrong, right? It's a little bit of deeper thinking, which is very good, right? But I wanted to stick with the rule, add positive numbers first, right? And then subtract. So this person went contrary and said, look, no, I'm not adding positive numbers first, right? I'm changing the problem to a totally addition problem because what? Addition, right? This subtraction sign, they convert it to a negative sign, which nothing is wrong with, right? I hope I'm not confusing the rest, right? I will tend to tell anybody to avoid this if you're a beginner, right? If you're a beginner, don't tread down that line, right? Don't tread down that line. Good. So with that now, we can actually do any problem that involves the order of arithmetic operation, right? So remember the little bit of memory aid, board mass, right? Board mass, right? It's more of a, what do you call it, an acronym, a mnemonic. A mnemonic is a memory aid, right? So you work out what the operations that are in the bracket, then powers of, then you do division, then multiplication, but these two can be done in the order they appear. You add positive numbers first, then you subtract, or you can do them in the order they appear, right? Good. So that's that bit there. We're going to do some examples and so later on. Don't worry yourself, right? This is just to capture everything. Good. So I wonder why this thing isn't moving. This, is it malfunctioning? It's not moving the why am I getting that? Oh gosh. Let me close whiteboard. Just give me a second, right? I'll stop sharing for a moment. Whiteboard is misbehaving, man. Let me open back whiteboard and see what happens. You usually take the hand and move the whiteboard. I don't know why it's not moving now. Give me a second, right? Yeah. Okay, good. So it's working good now. It's working well. Good. So from our course outline there, we talked about arithmetic operations. I want to jump over to this thing about the decimal system, right? So are you seeing my whiteboard or are you seeing something else?
Sir, seeing the whiteboard.
Go, great, good. So let's talk briefly about the decimal system. Decimal system, right? And there are lots of counting systems out there, right? Like in the computer, to represent everything in the computer, they use what you call a binary system, right? Binary system. That's a system utilizing two digits, 0 and 1, right? 0 and 1. That's another story by itself. Long ago, they had some other systems like the Babylonians and so. They had a system, you all know about the base 60 system, where they used to have, what is it? 60 seconds make 1 minute, right? 1 minute, 60 seconds make 1 minute, 60 minutes make 1 hour, 1 hour. That's really a base 60 system, right? When they use it to measure angles, they'll say 60 seconds make 1 minute and 60 minutes make 1 degree, right? Anyway, over the years, various number systems have come and gone. And the one that was really adopted universally is what we refer to as the decimal system, right? Now, in this system, okay, let me go back to this binary system to show you something. If you see a binary number, 1, 0, 1, 1, what this one means is 1 unit, right? 1 unit, or 1 times 2 to the 0 power, right? So every digit in the binary system is a power of, the place value is a power of 2. So down here, this 1 means 1 multiplied by 2 to the 1 power. This 0 means 0 multiplied by 2 to the 2nd power. This 1 means 1 multiplied by 2 to the 3rd power, and so on, right? Well, in the decimal system, what we have is this. Like when we have a number, well, the decimal system got digits from 0 to 9, right? 0 to 9. And when you see a number, let's say you see the number 123 point, let's go to decimals, right? 0, 1, right? So this digit means 3 multiplied by 10 to the 4th power. This one is 2 multiplied by 10 to the 1 power. Sorry, to the 2 power. No, that's wrong. This is 0, 10 to the 0 power. This to the 4th power. This one here means 1 to the times 10 to the 2nd power, right? After the decimal point, this one is 0 times 10 to the negative 1 power. This one is 1 times 10 to the negative 2 power. So what you're seeing here is that every digit has a place value that is a power of 10, right? It's a power of 10. And if you want a value of this number, you have to add up all of this. Work them out. So this is what? This is 100 plus, that's 20 plus, 3 plus, 0 plus 1 multiplied by 1. This means 1 over 100, right? 0.01, and you add all of them up and you get that back, right? That's a decimal system where every digit has a place value that is a power of 10, depending on where it is, right? Where it is in a number. And in this entire course, when you have to do, oh my, gone again to this. Why it's not moving this thing, man? Press space bar or mouse wheel. No, I wanted it to move like this. One thing when they modify this software, I don't know what it is doing. It's just shipping it. So it's um Uh, something is going wrong. Oh, it's moving now. All right. And why is that not erasing? Come on. It's not taking that out. Ah, well, this is the strangest thing. I've been using this thing so many years and I don't know what they did to it. Ah, all right. Let me change this thing. Give me a second, right? Give me a second. I've been using this thing all the time. Yesterday, the other day, all the other days, and I don't know what is going on. Um, okay, so hmm, 1 minute is working, 1 minute is not. Look here. You scratch here and you move it. That's what it's supposed to do. Yeah, good. So now that we are introduced to the decimal system, what you're required to know is how to do addition, subtraction, multiplication, and division, and even square roots and so, right? Square roots and that sort of thing, right? All right. Square, square roots and so, right? With these numbers. Now, for your class, right? You you are, I mean, you are not going to teach this to nobody, right? You don't have to teach this to nobody. You just want to know how to use them, how to do calculation involving decimal numbers. So let me illustrate what I'm talking. You have these numbers, right? Okay, you get 110.23 plus 11.495 plus 5.56. Let's say you have these three numbers to do. I mean, why will you go and now, okay, set them down like, you just do this in primary school? 11.495, 5 point. You have these three numbers to add. Will you do this? Will you do this? Anybody would do this? in the real world? Hmm? You all heard me? You all heard the question I asked? Do you do this in the real world? You have your boss comes up to you and say, hey, add up these numbers for me. Do you do this?
No, sir. Use the
What you do?
calculator.
Exactly. And therefore, I mean, we have advanced in technology. Unless you're a primary school teacher who is teaching this. Anybody's a primary school teacher here? Nobody's a primary school teacher. Therefore, what you do with it, to do all the arithmetic that involves decimal numbers, right? You use the calculator. So there's no need for me to go through now how to add decimals using this method here, right? Unless you are a primary school student, who has to learn this knowledge to preserve it or something, right? We have advanced to the point where we have a machine now that you are going to use a calculator or a computer or a cell phone, right? I have a cell phone in front of me and I do all my calculations with it, right? Where do I go find paper and write down, you understand? So you make use of the technology that you have, you see? Good. So there's no need for me to go through how do you add these numbers, how to subtract the number, how to multiply, unless you want to, maybe you want to get into teaching and you're going to be teaching this to primary school students, right? Because all the other schools, even CXC, you write exams with a calculator, right? And rarely, I mean, even in the multiple choice that you have in CXC, you're not using a calculator, but they're not going to give you something elaborate like this, right? They're going to give you numbers that work out very nicely most of the time, right? So you have a problem of this sort, take your calculator out. I mean, you're doing a test for me. Take out your calculator and add the thing up quick, right? If I ask you to calculate percentages and so on, don't waste time and write it on paper and, 5% of 100, of 1,000, and you put in five, and working it out little by little. Use your calculator, right? So there's no need for me to go through the arithmetic of addition, subtraction, because we ain't done. You make use of the technology that you have, your cell phone, your scientific I mean, your adding machine will do all of this, right? Your adding machine will do this. You wouldn't have to set out this thing like this and put on 5 there and 9 and 3, 12. And, no, you don't have to do that. Use your calculator, right? Good. Now that we have touched on that, I want to touch on one thing more this evening. And that has to do with, let me see our time, 6:36. All right. Let me talk a little about directed numbers. Right? Directed numbers, right? And by this, what we mean is we're talking about negative and positive numbers. Negative and positive numbers. And I think a lot of discomfort comes when people have to deal with these here, directed numbers. This and the other topic that is mentioned in the first week, fractions. When people see these two things, they start sweating, right? So let's take this last one. We will touch on fraction Friday. Let's talk about this here. So let's talk about how you add them, how you subtract them, how you multiply them, how you divide them, right? Let's start with addition and subtraction. Let's deal with those two. Good. If you have a negative and a positive number, let's say, all right, you have -3 plus 4, right? When you have a situation where you have two different signs, right? What do you do? And when you have a situation, maybe when you have the same sign, Let's say go with -2, -5. Same sign, right? Well, the obvious one is like if you got 2 plus 3. This is +2 and +3, right? Same sign. This is a different sign. This is the same sign, right? And I remember when I was teaching my young daughter many, many years ago, you say when there's this, the sign is the same sign, what do I say? Same sign, sum. So what you do, you sum the numbers, right? 2 and 3 is 5, and you keep the sign, the same sign, plus, right? Down here, you got -2, -5. What you do? Same sign, you sum it. So 5 and 2 is 7, and you keep the negative sign. You think you follow that? Same sign, sum. Meaning you sum, you forget the sign. You sum the two numbers and you keep the sign. Right? When the signs are different signs, you find a difference. Right? Or you subtract. Good. So what you do here? You have 3 and you have 4. So you find a difference between 3 and 4. What's the difference? It's 1. But what sign do you put in front? The one with the larger magnitude. And I explained to you what magnitude means. Right? The 4 here is a number of larger magnitude than the 3. And therefore, the sign in front is a plus sign. So you put plus. Right? So remember that. Same sign, sum. Different sign, find the difference. Right? In the case of the sum, you keep the sign. In the case of the difference, you keep the sign of the one with the larger magnitude. And maybe we can, let me just throw up -5 plus 2. Right? Signs are different. What's the difference between 5 and 2? It's 3. What sign will we put in front here? The sign, the number with the larger magnitude is 5, right? What's the sign in front? It's a minus. Right? And that's what you put there. -5 is less than 2, yes, but -5, the magnitude of it is 5. So the sign in front there is what you will retain here. Is that clear? You think you're getting that? If you have two similar signs, -5, -2, you get, I think I got this one already, right? Maybe 3, all right, -3. The two signs are the same, so you add the two numbers, you get 8, and you keep the sign. Is that clear? Simple enough?
Yes, sir.
Good.
Yes, sir.
Good. Let's take multiplication and division. So there's some nice rules. Let me shift down here. Let's take multiplication and division. And the rules are the same for the two, right? If you take, well, of course, all of you know that if you multiply a positive number by a positive number, the answer is going to be positive. Same is true for division, right? A positive number divided by a positive number gives you a positive number. A positive number multiplied by, sorry, that's a multiplication sign, by a negative number gives you a negative. In the same way, positive number divided by a negative number gives you a negative. If you put it the other way around, it's the same thing. A negative multiplied by a positive is a negative. Right? A negative divided by a positive will give you a negative. And then a negative multiplied by a negative gives you a positive. And a negative divided by a negative gives you a negative. Same rule. Right? Same rules. Again, you're seeing a trend. And there's where let me tell you what this mathematics is about. Mathematics is largely for you to develop and see patterns. Right? You should see that, watch. When the signs are the same, the answer is positive. Watch here. Signs are the same. Positive and positive, positive. Negative and, oh, this should be a negative sign. Oh my. Negative and negative. Okay, we made a mistake here. Positive. Nobody didn't correct me. Right? When the signs are the same, look here. The answer is positive. You see that? So we had an error here, right? Negative divided by negative is a positive. When the signs are the same, your answer is positive. When the signs are different, like you see here, the answer is negative. So there's a pattern to the whole thing. There's a pattern to the whole thing. So with this now, you can be able to work any problem that involves negative and positive. There's the peculiar situation. I just want to mention this here. Like, okay, look at this. Let's say you have something like this. 2, okay, minus 3. What you could do, you could treat these two as though the signs are multiplying, right? So negative and a negative gives you a positive, and you get 5, right? That's a shortcut, right? There are various approaches people show you with the number line and all of that, right? No problem with those. What we can do, I will put together some problems we'll do like a tutorial session on Friday, right? So just before we go into fractions, we'll take Friday and we're going to do a lot of like the order of arithmetic operations. I'll incorporate some negative and positive numbers, right? And after we have done a couple of questions, then we'll get into fractions, right? Good. So what we'll do, today is our first day. Where am I?